Hello, everyone, and welcome to another um, question from the classroom video. This question is one that I wanted to go over. I thought it might give you some potential problems, and it does give us a couple of things to actually discuss. One of them being, as I'm sure you're aware by now, that on some of these integral problems that we're going to be doing, as well as other problems that we're going to be doing throughout the course, but especially in this chapter on integrals, sometimes there's more than one right way to evaluate an integral. And this is one of those problems. And so this is number 23 from 7.3, the section on trig substitutions. And it says x over the square root of the quantity x squared minus 7 dx. So the u-substitution is pretty straightforward. I make a u-substitution for the expression under the radical in the denominator, which is x squared minus 7. My du is then the derivative of this, which is 2x times my differential dx. And because I have to make a substitution for x dx, I'm going to say that 1/2 du is x dx. So that gives me the integral of 1/2 du. And then I have the fraction underneath. So it's 1 over u to the 1/2 because I express this radical as the expression to the 1/2 power. I pull out the constants. 1 over u to the 1/2 becomes u to the negative 1/2 du. Notice I haven't evaluated the integral yet. I'm just rewriting it. And then if I make that, if I then go and apply the antiderivative, the power rule, I'm going to add 1. So negative 1/2 plus 1 is u to the 1/2. I'm going to divide by 1/2, which comes from the power on the u. So I have the 1/2 coefficient, and I'm dividing by 1/2, which means I'm multiplying by 2. So 1/2 times 2, and then u to the 1/2 plus a constant. 1/2 times 2 is 1. So I have u to the 1/2 plus a constant. And we know u is x squared minus 7. So I have x squared minus 7 to the 1/2 power, which is just the square root of x squared minus 7 plus a constant. So this resolves fairly easily something that looks a lot worse than it is. Now, the second method is considerably more difficult, but I wanted to show it here just to show you how the trig substitution sometimes is not the most direct, but it will work here. And this is one of the forms that we generally have 3. You know that from the chart. If you go and look at the chart, we have the same problem. The form here under the radical is x squared minus a squared, where a is the square root of 7. Notice that 7 is not a perfect square, but I can write this as the square root of 7 squared. So remember that that's a trick that we use often. So a is the square root of 7, a squared is 7. So the substitution that we're going to use is a secant theta. So a is the square root of 7. It's the square root of this constant. So square root of 7 times the secant of theta. Remember that the derivative of the secant is secant theta times tangent theta d theta. So then my dx is the square root of 7 secant theta tangent theta d theta. And then it's about plugging it all in. So I have x, which as we know is square root of 7 secant theta. And that is this here, square root of 7 secant theta That's my x. My dx, which I went ahead and put in the numerator, is this expression, square root of 7 secant theta tangent theta d theta. Then I have the square root under here, my x again squared. Notice here I'm squaring a radical under the radical, which looks like it's going to be awful, but it's not actually too bad. Minus 7. If I now clean this up on top, I get the square root of 7 times the square root of 7 is 7. Secant theta times secant theta is secant squared. Tangent theta d theta. And on the bottom I'm squaring everything in this first parenthesis under the radical. So I have 7 secant squared theta minus 7. I'm not squaring anything here. It was just 7 to start with, d theta. So now I have this expression. And if I left the top the same, the numerator of my integrand, I left it same. And I factored 7 from the bottom. So I factor out 7, not from under the radical. It's still under the radical, but it's out of the expression itself. And I get 1 minus secant squared theta. And if you've been watching my other videos, you know that this is tangent squared. I derive it from the Pythagorean identity. You're more than welcome to go look at that or message me if you need help with that. But this is indeed, this 1 minus secant squared theta is tangent squared theta. So we have the square root of secant squared, we have the integrand of 7 secant squared theta tangent theta d theta over the square root of 7 tangent squared theta. And then I returned this 7 into square root of 7 squared just to show you what would simplify. And of course, the square root of tangent squared is tangent. So now one of my square roots of 7 cancels, leaving me with the square root of 7 in the numerator. The tangents cancel each other, leaving me with secant squared theta d theta. So now my problem becomes the integral of the square root of 7 secant squared theta d theta. And this is equal to, remember, the integral of secant squared is tangent because the derivative of tangent is secant squared. So we end up with the square root of 7 tangent theta plus a constant. The problem here is that the original problem was in x. So I need to take this expression that I now have in terms of theta and rewrite it in terms of x. So what I do is I recall my substitution. X is equal to the square root of 7 secant theta. And so I have, that means that x over 7 is the secant of theta, or that square root of 7 over x is cosine, which that's personally easier for me to think about. I've drawn the right triangle over here for you. So I have cosine is adjacent over hypotenuse, square root of 7 over x, and then I did the little Pythagorean manipulation. If you need it, it's there for you. And b squared, which is this vertical leg, is x squared minus 7 under the radical. So that's these parts. Now I have to evaluate square root of 7 tangent theta plus a constant. Square root of 7, the tangent of theta is opposite over adjacent. So square root of x squared minus 7 over the square root of 7 plus a constant, the square root of 7 that was already there, cancels with the 1 underneath it, and you get square root of 7 tangent theta equals the square root of x squared minus 7 plus a constant. And that answer agrees with the answer that we got by the first method of direct application of u-substitutions. I hope that this problem's been helpful to you. Maybe that you learned a little something from it. And I'll see you in my next video very soon. Thanks for watching, everyone. Stay safe, be healthy, and I'll see you in my next video. Thank you very much. Bye for now.